在最后一个，然后这边前面家庭，他没有梦就可以了。不要。excuse us.
Hi, Jeremy, you're back.
Hi. Hi.
Hi, Mr. Benny Su's office?
Yes. Yes. Yes.
Yeah,
Hey,
yeah,
hi, Jess.
hi, Yi-Ming ma.
Yeah.
Hi, how are you? Good. Yeah, we have foreigner. Is all the speakers there?
Okay.
Can we start to broadcast our webinar and then we'll allow all the attendees to join us? We have about 210 participants today.
Okay.
Okay. Farana, are you ready?
I haven't seen her photo or.
Yeah. I think because they turned off the video. She has tested. Yeah, she has tested just now. Everything.
Okay. Perhaps a minute.
Yeah, I think they are there.
Can you hear? Can you see me?
Yeah. Yes, I can see you. Can we broadcast the webinar and allow about 200 participants to join us now?
Yeah.
Okay.
Hello, Mr. Benny Hu. How are you?
I'm
Jacob
fine.
Lee
How are you?
from Malaysia.
Good. Good to see you.
So you have to stay safe now, huh? Taiwan, the spike in the COVID cases, huh?
Yes, since last weekend.
Yeah.
It was a surprise to us.
True. But compared to Malaysia, you are still very good.
Yesterday we have 333 cases, record high.
Yeah.
Taiwan never had more than 300 one day, never.
Yeah.
So it was kind of serious.
But you get used to it, like what we are.
You're right. Did you have the vaccine?
Not yet.
Not yet.
I was supposed to have the vaccine last week, but I let it pass me because I had a steroid injection. So the doctor advised me to stop for another 2 weeks before to take the vaccine.
Right. You have a steroid. You need some time in between.
Yeah.
I had it yesterday.
Oh, very good.
But
the AstraZeneca?
AZ.
Yeah, AZ.
AstraZeneca.
Yeah.
Taiwan only has AstraZeneca. We have no other choice so far.
There seems to be a good one, except the worry for the blood clot, but that is such a...
Yeah, and mainly probably for Westerns.
Yeah.
Not many cases among Asians.
Mr. Rosmi, have you got your vaccine?
Not yet, Mr. Jacob. Still waiting.
Still waiting, huh? I think we need to roll out as soon as possible. Look at UK. UK used to have 40,000, 50,000 cases one day. Now it's only like 2,000 plus for a day.
Yeah.
So the vaccine has actually reduced the infections drastically.
Right.
True.
Now the slogan is, you are only safe when everybody is safe.
That's true. That is true.
Yeah.
You cannot only kind of, take care of yourself.
True.
Everybody else has to be taken care. You know, now the UK worry about the Indian variant.
Yes.
This variant is much tougher than the UK variant.
Yes.
So they
The
are
mortality
worried.
rate, the fertility rate is higher now.
Yes. Infection rate also higher.
Yeah.
So the Indian one could be a global problem. You know,
Exactly.
it's already penetrated to many countries. Many countries.
It's already in Malaysia, by the way.
Oh, really?
Yeah. Half time ahead, but Taiwan is still very good.
Oh, yeah. 今天多少个 case？
今天还没看，2点才知道。
哦，还差2分钟。
对，
听说很多。
一定很多。这照这样下去，如果是以英国跟美国的经验来看，应该是会整体指数增加。对啊。
对。坐，你坐。
Shall we commence the webinar? Okay, Mr. Jacob Lee? Okay. Ladies and gentlemen, I'm Jess of the FMM Secretariat and I will be your MC for today. We will commence the webinar in another 2 more minutes. Please allow me to make several announcements before we start the program. As this is a webinar and attendees are dialed in using different internet bandwidth and devices, attendees may or may not experience minor technical glitches. As such, please be patient if there's any. Please submit your question at the Q&A box, which will be answered accordingly during the Q&A session. Presentation slides will be emailed to the attendees after the session. Mr. Jacob Lee, FMM Council Member and Chairman of Malaysia-Taiwan Economic Cooperation Committee Business Advisory Group, MTECC Malaysia Chapter. Mr. Benny Hu, Standing Superior of Chinese National Federation of Industry, CNFI, and Co-Chair of Malaysia-Taiwan Economic Cooperation Committee, Business Advisory Group, MTECC. Mr. Rosmi Abdullah, Director of Organizational Excellence Development, Malaysia Productivity Corporation, MPC. Dr. Kuo-Ming Wang, Managing Director of China Productivity Center. Mr. Chien-Fei Chang, Deputy General Manager, China Productivity Center. Mr. Jerry Shu, ICP DAS Co Limited. Mr. Jui-Fang Liang, Vice Chairman, Accutex Technology Company Limited. Mr. Yi-Chang, Manager, CPC, fellow Malaysian-Taiwan Economic Cooperation Committee, Business Advisory Group, and FMM members. A very good day and welcome to the Malaysia-Taiwan Collaboration Webinar on Smart Manufacturing. To begin this afternoon's program, allow me to invite Mr. Jacob Lee, FMM Council Member and Chairman of Malaysia-Taiwan Economic Cooperation Committee, Business Advisory Group, to deliver the opening remarks. Over to you, Mr. Lee.
Okay, thank you, Jess. Good afternoon, ladies and gentlemen. Since Jess has given the salutations to all our VIP here, I will just go straight forward to my speech. Ladies and gentlemen, a very good afternoon. I'm very pleased to welcome all of you to the Malaysia-Taiwan collaboration webinar on smart manufacturing, organized jointly by the Federations of Malaysian Manufacturers, FMM, Chinese National Federations of Industries, CNFI, and China Productivity Center, CPC, with the kind support of MPC, Malaysia Productivity Corporation. Before we begin this afternoon's webinar, allow me to give you a brief introduction of the Malaysia-Taiwan Economic Cooperation Committee Business Advisory Group, MTECC. The Ministry of International Trade and Industry, MITI, and the Bureau of Foreign Trade, Ministry of Economic Affairs, Taiwan, BOFT MOEA, had established the Business Advisory Group, BAG, under Malaysia-Taiwan Economic Cooperation Committee, that is MTECC in short, in 2019 to allow for deeper engagement with the private sector on matters pertaining to trade, investment, and SME development. FMM has been appointed on September 13, 2019 as the chair and secretariat of MTECC Malaysia, and our counterpart in Taiwan, Chinese National Federations of Industry, CNFI, is the chair and secretariat of MTECC in Taiwan. Today with me is my co-chair in Taiwan, Mr. Benny Hu. So this MTECC will support and provide MTECC with recommendation to facilitate and foster bilateral trade between Malaysia and Taiwan. Ladies and gentlemen, there's no denying how catastrophic effects of the pandemic have affected everyone's life and our livelihoods. Many businesses, to survive COVID-19 were forced to rethink, reposition, and rebuild to adapt to the new normal environment that involve constraints on human interaction and risk mitigations regulations. This means expediting the adoptions of the fourth industrial revolution, Industry 4.0 principles and technology to help lower costs and increasing our levels of productivity. This afternoon's webinar is one of the testaments of the importance and benefits of technology, which allows us to bring to you international experts from Taiwan to share experience and best practices on their Industry 4.0 and smart manufacturing journey. This webinar is jointly organized by FMM, CNFI, and CPC as one of the initiatives under MTECC. On behalf of FMM, I would like to express our appreciation to the speakers for their willingness to share with us their expertise and experience through this webinar. And I hope you will find today's webinar informative and beneficial. And please also take full advantage of the Q&A session scheduled at the end of the day to share your views and experiences, raise your queries, and seek clarification from the speakers. I thank each and every one of you for your support and attendance today. In conclusion, I would like to record our appreciation to MPC and CPC for their support, which we are confident would benefit Malaysian industry. Have a fruitful and enjoyable seminar. Thank you very much. Back to you, Jess.
Thank you, Mr. Lee. Next, I would like to invite Mr. Rosmi Abdullah, Director of Organizational Excellence Development from the Malaysia Productivity Corporation, MPC, to deliver his opening remarks. Over to you, Mr. Rosmi.
Thank you, Jess. Okay, Mr. Jacob Lee, FM Council Member, Mr. Benny Hu, Standing Superior of Chinese National Federation of Industry, Mr. Chien-Fei Chan, Deputy General Manager, China Productivity Center, fellow Malaysia-Taiwan Economic Cooperation, Committee Business Advisory Group, and FMM members. Distinguished guests, speaker, representatives, ladies and gentlemen, welcome to Malaysia-Taiwan webinar session on smart manufacturing. First and foremost, I would like to welcome all the participants to the webinar on smart manufacturing, which is held to enhance our understanding on the application and benefit of smart manufacturing and Industry 4.0 technology to our businesses in Malaysia. I would like to thank FMM for inviting MPC to attend this seminar and always support MPC in continuous improvement program such as lean manufacturing, Industry 4.0, and others. This collaboration between FMM and MPC has increased the productivity and competitiveness of the industry in Malaysia. MPC also hope to learn the approaches and method of CPC and CNFI in implementing smart manufacturing to the industry in Taiwan. From the paper will be presented today, I can say that the company in Taiwan already advanced in smart manufacturing and Industry 4.0. This initiative can help our industry and SME manufacturer understand the importance of smart manufacturing to achieve greater business productivity and competitiveness. Ladies and gentlemen, with the introduction of My Digital Blueprint that will help enhance Malaysia's comparative advantage in the global digital economy landscape, Industry 4.0 will be the mainstay for business digitalization. Accelerating digital empowerment to enrich the life of Malaysia is the best and the sure forward. And that's why the webinar today is very important for all of us. In Malaysia, the government has allocated nearly 200 the period 2019-2021 to support the transition and mitigation of SME to Industry 4.0. The Malaysia Productivity Corporation has been given responsibility to carry out readiness assessment since 2019 till now. Industry Forward Readiness Assessment is very comprehensive program to have our firm assess of their capabilities and readiness to adopt Industry 4.0 technology and processes. The assessment uses a predetermined set of indicators to understand their present capabilities and gaps, from which will enable firm to prepare strategy and plans to move towards Industry 4.0. This program will help our firms to determine their state of readiness, the adoption of Industry 4.0 technologies, identify the gaps and area of improvement for Industry 4.0 adoption, opportunity for productivity improvement and growth of their businesses, and develop the feasible strategy and plans to perform outcome-based intervention projects. The Economic Action Council meeting that was chaired by Yang Ahmad Berhad Prime Minister on 20 July 2020 has given Malaysia Productivity Corporation, MPC, the mandate to implement Malaysia Mudah program or My Mudah as a non-fiscal measure to support business recovery in the wake of COVID-19 crisis. The main objective of My Mudah is to assist business from being burdened by unnecessary regulation and reduce the cost of doing business, while at the same time supporting job creation and stimulating economic growth. Through this program, the policymaker and regulation that or permanent abolish, modify, waive or exempt any unnecessary regulation imposed on businesses in Malaysia. The implementation of aim of My Mudah is aimed to achieve 20% of equivalent to 10 billion ringgit Malaysia reduction in compliance cost by ministry and state government, including reduction the number of the procedure and processing time imposed to industry and business level. Under this program, all businesses are urged to lodge their regulation concern through Malaysia Mudah or My Mudah, reducing unnecessary regulatory burden to support economic growth. Stakeholder consultation, which is available online at the Unified Public Consultation (UPC) portal. That means all the business can can report any issue on regulation to this UPC portal, which is the portal is upc.mpc.gov.my. Ladies and gentlemen, Malaysia needs to keep pace with the rapid advance in technology and position itself at the right skill to stay competitive, enhance productivity and efficiency. To this end, we would like to call on the industry in Malaysia to adopt Industry 4.0 and smart manufacturing to ensure they competitive and survive in any unnecessary crisis. Finally, I hope you will fully benefit from this webinar session and continue to take opportunity to participate in the smart manufacturing program collaboration between FMM, CPC, and CNFI. Thank you, FMM, CPC, and CNFI for organizing this seminar. Thank you very much.
Thank you, Encik Rosmi. Next, I would like to invite Mr. Benny Hu, Standing Superior of CNFI and Co-Chair of MTECC for the opening remarks. Over to you, Mr. Benny. Mr. Benny, you are muted.
Hello. Can you hear me now?
Yes, can.
Okay. Dear Mr. Jacob Lee, Mr. Rosmi Abdullah, Dr. Kuo-Ming Wang, ladies and gentlemen, good afternoon. Thanks to everyone for being here with us today. I'm privileged on behalf of the Chinese National Federation of Industry, CNFI, to welcome you for Malaysia-Taiwan collaboration webinar on smart manufacturing.
Is it all correct now?
Can you see me?
Yes, we can.
Oh, okay. Malaysia has been one of Taiwan's significant trading partners, as well as valuable partner in Asia. Malaysia has been the 7th largest trading partner of Taiwan. Our bilateral trade reached $19.3 billion last year. CNFI and FMM, as the most important organization of manufacturers in Taiwan and Malaysia, have been closely collaborating in promoting industry cooperation between two countries. So far, we have established two platforms: Taiwan-Malaysia Industrial Collaboration Summit and Business Advisory Group. Since 2017, the Taiwan-Malaysia Industrial Summit was held each year. On this platform, 36 MOU has been signed, covering textile, food, and bio products, smart city, and IT services. The 2021 summit is scheduled to be held on September 7th to 9th. The other is the Business Advisory Group, BAG. It was established in 2019 under the Malaysia-Taiwan Economic Cooperation Committee, which is an intergovernmental platform to formulate economic cooperation between Malaysia and Taiwan. The BAG has had its first joint meeting on October 23, 2020, and I have 28 members categorized into 5 sectors as smart manufacturing, information services, startups, entrepreneurship, medical devices, and the halal industry, as well as logistics. In this meeting, we reached 7 recommendations and had been advised to the MTECC. One of the 7 recommendations is to organize a small manufacturing workshop program with models from Taiwan-based Consulting Institute, China Productivity Center, CPC, focusing on the best practices of Taiwan industry, which can be implemented in Malaysia manufacturing industry. Thus, CNFI attempted to introduce FMM to CPC to promote the cooperation between CPC and FMM, as well as establishment of today's webinar. I believe that CPC, as the top provider of smart manufacturing training and enterprise consultation for competitiveness raising in Taiwan, able to introduce Taiwan advanced smart manufacturing technology and module to Malaysia. Hence, the closer collaboration of smart manufacturing between Taiwan and Malaysia further can be expected. And there will be more business opportunity for us, for both of us. For this reason, I'm glad to see CPC to share the Taiwan experience of developing smart manufacturing. I'm looking forward to establishing a collaboration between Taiwan and Malaysia smart manufacturing to create new value and profits. Thank you for your attention, and I wish the webinar the best success. Have a wonderful day. Thank you.
Thank you. Thank you. Thank you, Mr. Benny Hu, representing CNFI for the opening remarks. Without further ado, I would like to invite representative from CPC, Dr. Kuo-Ming Wang, the Managing Director of CPC, to deliver the opening remarks. Over to you, Dr. Kuo.
Mr. Jacob Lee from Federation of Malaysian Manufacturers, FMM. Mr. Rosmi Abdullah, Director of Productivity Advisory and Consultancy Services, Malaysia Productivity Corporation, and Mr. Benny Hu, Chinese National Federation of Industries. Distinguished guests, good afternoon. On behalf of CPC, I will serve as the chair of the webinar. In attendance in the meeting with me include Mr. Chien-Fei Zhang, Deputy General Manager of CPC, as well as Mr. Jui-Fang Liang, Vice Chairman of Accutex Technologies, and Mr. Jerry Shu, Manager of ICP DAS Company Limited. Also joining us is Mr. Li and Mr. Tsai from CPC, as well as other colleagues from CPC. I'm very grateful to FMM, MPC, as well as CNFI for making possible today's Malaysia-Taiwan collaboration webinar on smart manufacturing. So I'd like to extend my appreciation to all of you. CPC, since its inception, has been 66-year-old. We have been promoting government policies, especially corporate consultancy for smart manufacturing. We have made a lot of achievements over the 60 decades. And I have been involved in the setup of academies, promotion of government policies for over 40 years. In April 2019, the APO decided to set up the APO Smart Manufacturing Excellence Center. It is hoped that Industry 4.0 and best practices in this area will be better shared among all APO members. Especially, we would like to start cooperation with countries in Southeast Asia. Recently, Taiwanese government has been promoting 5+2 key sector development. The technology experience in relation to smart manufacturing in Taiwan have been advancing very rapidly. I'm sure we will be able to share our know-how with our Malaysian friends. especially by working with FMM and MPC, we will be able to have more opportunities for further collaboration so that Malaysian manufacturers will accelerate their upgrade in smart manufacturing. In today's agenda, we will have experts on smart manufacturing as well as representatives from the industry to share their firsthand experience and insights. You will see the capacity we have here in Taiwan in this area. I will wish you good health and happiness. Thank you for your listening.
Thank you, Dr. Kuo. I will just have to inform that Mr. Benny, who has to leave for another meeting. Nevertheless, we will proceed with our webinar today. Okay. Thank you, Dr. Kuo again. Ladies and gentlemen, to proceed with this afternoon webinar, allow me to invite Mr. Chien-Fei, Deputy General Manager of CPC, to present on the topic CPC Lean Smart Manufacturing Implementation Method and Structure. Participants can put forward your question in the Q&A box available at your screen. Mr. Chang, I now pass the floor to you. Thank you.
Mr. Jacob Lee. Mr. Jacob Lee from FNM and Mr. Abdullah from MPC and dear friends here in Taiwan, good afternoon. Well, actually, we planned to have friends from Malaysia coming to Taiwan to attend the seminar. However, because of the pandemic, we have to switch to the online platform so that more than 200 business people in Malaysia can join us in this discussions. I would like to introduce to you LSM, Lean Smart Manufacturing. This topic basically was born about 2 years ago. Why did the CPC come up with the idea, LSM? Well, I'm sure you have heard of Lean management or Toyota management, and this can be related to smart manufacturing. However, there's very little literature looking into the relations between lean management and smart manufacturing. So 2 years ago, I began to conduct some research. 2 or 3 years ago, actually more than 1 year ago, in one of the strategic meetings we held here at CPC, Chairman Shu declared the strategic objective to help more industry to become more efficient and effective. And President of CPC, Mr. Zhang, also told us that we should build on lean management so that we can develop lean smart manufacturing. This is how LSM came into being in the first place. So what are the relationships between the two concepts? Many people think smart manufacturing is just about automation and the use of a lot of information technology. That's not right. Actually, smart manufacturing must be integrated with management. So many people in the industry may feel that there's nothing wrong with our manufacturing processes. However, the efficiency or performance are just not as satisfactory, or the automation level of the production line varies greatly, and there are new machines and old machines. And how can we make sure that our smart system is fully integrated with our existing manufacturing system? So if we can put into place lean management, we will be able to make more efficient and effective use of our resources. And when planning production processes, we can also take into the industrial transformation. Data collection can be better combined with our management and performance management analysis. At the end of the day, we want to have real-time combat situation analysis. In other words, LSM will be the key to solving all the problems faced by the industries. LSM, simply put, aims to build on green energy technologies, providing lean management and services, and by applying the CPS, we will fulfilling the development of Industry 4.0. Speaking of smart manufacturing, there are 3 objectives. First, flexible production, better meeting needs of the market. We can have zero waste. Of course, smart system will be able to detect mistakes in the process and system. Ultimately, we hope there will be zero failures, zero accidents, and zero pollution. The CPC team has come up with this particular framework. About more a year ago, actually at the end of last year, we published the report on LSM. To start with, under this framework, there are 6 tools. I will go through them one by one. The first one is, how do we use smart technology to achieve automation?
There are 2 cornerstones of Toyota style production. The first is Kanban. The second is automation. But today, we use one smart Kanban, or S Kanban, or SM Kanban, or some people call it E Kanban. The second is E automation, or some people call it S automation. I'd like to introduce the first one first. When it comes to automation for Toyota style production, it means that there should be a warning in the event of automation equipment anomaly, and there will be automatic calibration or automatic suspension. In the past, we use human efforts to conduct statistics, observation. We hope that in the future, we can leverage sensors to analyze data. In other words, what do I mean by smart application? That is to allow the equipment to predict problems so that we can prevent the occurrence of problems in advance. Secondly, with respect to parameters for chemical plants, In the past, we use a lot of labor. We hope that in the future, we'll be able to leverage the sensors to provide information to the control center. And then we can record all the data. And then in the future, we'll be able to trace all the data for our purpose. I just talk about automated equipment or machinery aspect. But what about assembly lines? How do we deal with assembly lines? I can give you some examples. When you deal with shop floors, there may be circumstances of poor performance or defects. We use different lights to indicate the status, and the measurement is we use some kind of a Vernier caliper to take relevant measurements. But I don't know whether you have thought about that. After SPC, the data in the morning cannot be shown until this afternoon. The production has been completed already. That will be too late. We hope that in the future, through our smart system, through our Vernier caliper, we'll be able to transmit data on a real-time basis so that we can address efficiency issue on a real-time basis or quality issue. If the defect rate is too high, the information will be pushed to the phones of various supervisors proactively. Now let's talk about the level of equipment. As we all know, before a piece of equipment fails, take a motor, for example, before it fails, the bearing will be very noisy and the temperature will be higher. In the past, vibration will be higher. In the past, we use our ear to hear and we use our hands to touch and feel the vibration. But in the right, we can set up, as you can see, we can install a sensor. The sensor will record vibration, noise, and temperature information and send it to our visualization system so that we can understand the status of the equipment on a real-time basis. So this is about how we can transform automation into smart applications. Then I'm going to talk about real-time reporting to implement just in time. But some concepts are quite interchangeable or common. Let me cover all these concepts together. First of all, when it comes to smart Kanban, for traditional Kanbans, they are used for lean management or Toyota productivity management. The Kanbans were used to deliver process data, and the Kanban is used to identify or to show information about the materials that should be prepared or to the station to which the materials should be delivered. But now we can use our phone or our computer screens. We can transmit real-time information about the production progress and also working process information and the quantity involving work in process. So we can understand the dynamic information on a real-time basis. And the information can be used for preparation of materials. And then we can further implement or carry out just in time. Because for Toyota style production, they use Kanbans to deliver on-site information when it comes to material preparation or material requisition. The Kanbans can be inserted to indicate whether the materials have been received or the stage of material preparation. Here you can see this kind of information through the Kanbans. However, the drawback is that you need to come to the site in order to see all the information. However, if your work job location is not here, it will be very difficult for you to gain access to the information. But we hope that we can use our cell phones to understand the current status of material preparation, material requisition, or material request and scheduling, so that we can support the promotion of JIT. When we are doing material preparation or scheduling, we could use Kanban, as I mentioned previously. Another thing is that we can reduce our different categories of waste. In the past, we use a fixed quantity, a fixed location. And in the past, we also use Kanbans or cardboards or bulletin boards or other visualized material labels, or we can use 3 different colors of light on the machine to indicate different statuses. And through the different lights, you can see whether the different status of operation. The red indicates abnormality. So it can show you information for the purpose of management. So in the future, this is not what we want for LSM. We hope that we can have a control room style of information display, so that for different work sites or different production lines, information will be displayed on a real-time basis. And on the processing line, we can use set-top box to transmit information on a real-time basis. On the assembly line, we can transmit information about the quantity of the products handled, and also the status of the material preparation. The information as such can be integrated and can be accessible on a remote site. Now I'd like to talk about things about factory networking practice. Recently, particularly people in Taiwan, have been talking about digitalization or digital equipment. In the past, we dealt with analog equipment, and now we are looking at digital equipment and also optimization. And before the era of ERP, in the past, we have warehousing system, accounting system, production, operating systems, which are separate. Now they are integrated into ERP. But ERP is a management system. But for production lines, there is a production system. For business aspect, there is a business system. And also for supply chain, there is SCM. So in the field of smart manufacturing, we will need to integrate or connect different systems, including the equipment, so that we can optimize the equipment, so that we can achieve digital transformation, so that we can achieve C2M or C2B. So the key to LSM is to connect different equipment. In the past, the weakest element is production information in the context of ERP. For the picking of materials, distribution of materials, the quality status, or the dispatch of labor, we need to use bulletin boards or forms or oral communication to communicate with the production site. And the production information on site, as well as efficiency and progress, such information could be communicated through daily production report, or can be typed into the computer system. For daily production reports, usually they are input the following day. So you only see historic data. For SPC quality data such as SPC, you'll be doing you would do a good job if you can generate the data in half a day. So you can see some kind of gap in terms of information. So through digitization, we can improve the linkage of different data. In the past, when it comes to TPS or lean management, all the production information was communicated through light signals or through Kanbans. In the future, under LSM, with respect to equipment, we'll use set-top boxes, and for assembly line, it has to be highly customized. We need to have better control of different work pieces, and then for the material warehouse, for the warehousing or the area of the materials, we can use SCADA or MES or ERP. We can connect different data streams on a real-time basis, so as to achieve what we call a digital linkage. So that's why we have come up with a simple structure like this. In the context of production line, we have our equipment, assembly lines, through PLC. Why do we need PLCs here? Because sometimes you may heard of the term I/O links. For smart sensing and measurement, we can use I/O links for sending information to SCADA. Another way is to use PLC. PLC is not only for control. You can transmit data to sensor, and then the information can be sent to SCADA. And this is the architecture. And then through our computing, we can provide or display the information on a real-time basis in a highly visualized manner. So after such data connection, our production data or dispatch of labor or material collection can be, we can generate integrated data, and on site we can have a real-time dispatch of labor, and also we can transmit data or transmit on-site data on a real-time basis to the ERP and to the business system. And the whole structure is highly digitalized.
接下来
Next, we would like to talk about digital real-time control and command. To begin with, traditionally, before smart technology was available, we relied on the lights or status on the efficiency, quality, or quantity, the LED lighting, or we have a whiteboard on which we wrote down the progress. Or sometimes we would issue alerts or warnings in a manual way to our staff. But this is a thing of the past. In the future, we're going to present everything from real-time efficiency analysis, performance analysis, management, operational data. Once collected, will be computed, and then they will be linked to ERP and MES system immediately. As a result, the production data can be visualized in a real-time manner, transcending time and space. let me say it again, production information to the far left, of course, will have to be linked with costs so that we can produce adequate budgets. Therefore, efficiency is embodied not only in production, but also in operational efficiency. We can set a range of KPIs to review the production efficiency. So we will be able to predict and preempt any potential problems. All the parameters on different machines can be calculated, computed based on the big data technology. So the parameters of different machines, how each machine is running, can all be monitored in real time. Last, I would like to focus on value chain operation. With all these new models and technologies, what are the contributions to companies and industries? I think, as you can see in this triangle, this is a very common framework from SAP. Actually, it proposed this new model that is, in addition to management as the basis, we have to combine production with the business management system. This is how smart manufacturing can be differentiated from traditional models. In other words, this is a market-oriented model. Now, in Europe, especially Porsche, basically, now, if you purchase a Porsche, the vehicle itself is not that expensive. But if you want something tailor-made, either the wheel or the tire, for small parts of tailor-made elements, it will cost you more. Customization is the key. As a result, manufacturers usually would have bulk production of very standardized products and items. In the past, such products will be distributed to customers. In other words, the manufacturer would decide what products to produce, and they would sell such products to customers. But in the future, the customer will determine what products should be made in the factory. As a result, there will no longer be distributors in the middle. Rather, customers will purchase the tailor-made product from the maker directly. So this is a more customer-facing model. However, in this C2M model, there are three dimensions. The first one is people. For example, in Taiwan, retailers had some questions about manufacturing. I was asked very often whether or not there is also Industry 4.0 in the retail sector. I would say the convenience stores, the 7-Eleven convenience store would be one example of Industry 4.0 applied in the retail sector, because at such convenience stores, their POS would be able to provide weather forecasts along with the products they sell. As you can imagine, when it's hot, cold drinks will sell very quickly. When the weather is cold, then hot food will sell, like hot cakes. And that's how convenience stores would know what products they need to build more stocks of. However, the convenience store has evolved to include mobile payment as well. So that's an example of the implementation of Industry 4.0 in the retail sector. So the retailers are catching up. If you can collect data on customers' experience, you will have a better idea what your customers are looking for. You know what they like or dislike. Well, let me give you another example. A company I have worked with, it's a apparel company. It makes clothing for young girls. We know that young children are very well nourished. As a result, they may seem taller or heavier than young children are supposed to look like. As a result, the apparel business will have to make adjustments, especially with low fertility rates. Each child is very much valued and treasured by their parents. So you can imagine you need to collect data on your target audience or customers. You can build a membership system so that you can collect their data. You may think, well, but we cannot collect personal data of young children, but we know who are buying clothes for young children. It's their mothers. That's why you need to know what these young mothers like to buy for their kids. Secondly, we have to know what products we are talking about. Well, maybe you have noticed that people are accustomed to wearing specific kinds of clothes of particular fabric. Some like checkered patterns, some like one-piece dresses, some like cotton clothes. So when trying to identify customers' needs, we can identify the fabric of their preference, the length of the sleeve their customers prefer. So this is how we collect preferences of our customers. But there are more details to pay attention to. For example, maybe they like to have ruffles, maybe they don't like to have buttons. With such knowledge, you will be able to notify your customers when you have new clothes coming into your store, which meets their preferences. We know that for customized products, the cost will rise on average by 20%. So if you already have such information in hand, you will be able to meet their needs without having to pay such a high cost, additional cost. If you have membership, it's very easy for you to know their preferences. However, production is still the key. When you purchase raw materials for your production lines, you have to use technology to help you to save cost. That is why smart manufacturing can come into play. Next, whether it's to aim or to be, we are talking about omni-channels. If a factory is serving makers or customers. Well, if we are talking about a brick and mortar store, a department store, for example, the department store can sell products in the store or online. Well, do you think you can call yourself omni-channel provider if you have online websites as well as brick and mortar stores? No, you are multi-channel provider at best. You need to have digital connection to become omni-channel player. So, in conclusion, CPC in the past couple of years has used iBench to provide online diagnosis and assessment. In addition, we help factories to become more optimized. We provide consultancy and mentoring. Digital link is then built. Like SAP says, you need to have optimal process and talent development so that you can achieve the goal of LSM. That concludes my presentation. Thank you.
Thank you, Mr. Chien-Fei Chang, for the presentation. Next, I would like to invite Mr. Jerry Shu, Manager of ICP DAS Company Limited, to brief us on his experience in setting up smart factory. Participants can put forward your question in the Q&A box available at your screen. I shall now pass the floor to you, over to you, Mr. Jerry Shu.
Good afternoon. I'm Jerry Shu from ICP DAS. I would like to introduce to you our experience in setting up smart factory. To begin with, I'm here to represent our company, ICP DAS. Our company is focused on research and innovation. It is committed to the development of smart solutions. We develop software as well as hardware. As you can see, we provide a range of solutions. In Taiwan, Malaysia, Thailand, or Vietnam, the manufacturing industry is facing a number of problems in the production process. Usually, the production line may have problems, whether or not the machine is running adequately, how efficient are the machines.
So basically, we have make our very important first step based on these systems. This slide compares a conventional factory and a digital factory. The first is the timeliness of data. We can use real-time data instead of historic data for analysis. Regarding the streaming of data, in the past, in the course of promoting Industry 4.0, it's very important for companies to look at their own status. They may be at a stage of 1.0 or Industry 2.0. They have different stages. For different companies with different backgrounds, how can they implement their smart manufacturing plans? I think they first have to consider their own situation. If you have mostly Industry 1.0 or 2.0 machinery, you need to connect data through I/O, or you may need to set up additional sensors to obtain data. If you have more, if machinery above Industry 3.0, my recommendation is that you can extract data from the internal data module. As shown on the slide, for example, you can see Siemens PLC or Mitsubishi PLC. You should be able to obtain data directly from the machines, or you can use a communication or additional sensors. And then through the IoT, the information or the data can be streamed, and then you can obtain real-time data. And then you can conduct smart analysis, and then you can provide your feedback for decision making. This is a very important step. So originally the data were delivered manually. Now we can combine the data for real-time feedback and decision making. Let me give you an example. When we are monitoring the status of machinery, we can set up a sensor. We call that a smart meter. And the function of the smart meter is to sense the status of the machine. In this example, the machine is working on the heating of plastics or the drying of plastics. The heater, the operation, let me make a correction, Robert, we need to control the voltage and the current of the machine. If the current is too high, that means the heater has malfunction. If it continues to operate, there may be a fire that may be triggered by the failure, and then or it may trigger quality issues. So by monitoring the current, we can prevent fire hazard. And secondly, we can avoid defective or quality defects. Another example is about the shoe making business. There is a step regarding gluing, and the temperature control is very important. In this example, we set up a temperature sensor, and then we can apply glues to both sides of the shoes. After the glue, the shoes they'll go through ovens. So the temperature control is very important. You can see up, medium, and downstream temperature points. So the IoT sensor should be set up at the appropriate location, and the data will be generated continuously. And then you can understand the temperature curve at different stages. And then we can trace the importance of the temperature based on the quality of the products. And then we can set proper temperature parameters. And then we can set up relevant warning thresholds for the temperatures. And also in the production process, we can use this kind of caliper, and the caliper can be used to take a measurement at different points. In the past, we did that manually, and there are time lags. Now we use Bluetooth technology, and the data from different points can be transmitted and recorded directly in the back office. And also for predictive maintenance, for important equipment such as motors, we can use sound, current, or vibration to diagnose or to predict the current status of the motors. But if you have a 3-in-1 sensor, also by measuring the current, we can predict we can engage the health status of the motor to see whether the motors require further maintenance. Or if we go even further, we can further analyze the data, and we can find the causes for past failures of the motors. In Taiwan or in Southeast Asia, whenever we are promoting smart manufacturing or Industry 4.0, one very important thing to bear in mind is that we often consider our needs first. And our company provides solutions beginning with the various points. That is based on the pain points of the companies. And then we set up our IoT equipment. If you have requirements for temperature surveillance, we'll start with temperature surveillance. If the use of electricity is important, we will start from there. And then we can gradually create a line by connecting different dots. And then we can create a two-dimensional application. So from dot to line to planes. And then the data can be streamed or combined together, and then we can feed the data into the ERP. Let me share with you a real case. And this case involves an oil extraction industry, and this company extract palm oil for sale. This company is very successful. The palm oil is sent directly to a cosmetic factory or the food factories for sale. And on site, they have 16 oil press machines. However, while they are promoting or enhancing productivity, they have several issues. For example, they don't have ideal material feeding system, and sometimes they may be jamming, and also the machines may fail because the oil is created by pressing, and the gear shaft sometimes is damaged, and also the maintenance cycle is quite long. So they were thinking about leveraging Industry 4.0 to address the issues. And under our company's advice, they set up some IoT sensors on their machines. Actually, it's a smart meter. For each oil pressing machine or motor, we set up a smart meter, and it will generate very important information. To the right, you can see into the left, you can see the smart meters being set up, and all the electrical current data are recorded. If you look at the lower right, you can see a red line and a blue line, a green line. You can see this graph depicts the operating efficiency of the machines. The green line indicates that at about 8 o'clock, the machine is turned on, the materials are fed, and after 12 p.m., the green line starts to fluctuate. So you can see the situation about the change in performance. And then we can enlarge the graph. Now that we have set up an IoT sensors or the smart sensors or smart meters, we can collect data for the entire day. And we can learn that the operating efficiency of the factories is better in the morning, and the performance dropped in the afternoon. So after collecting the data, we can try to interpret the data and then try to make improvements. The data are real-time data that are recorded or extracted from IoT controllers, and they are also stored in the IoT controllers. So the first step for smart manufacturing is that with respect to production line issues, we should first identify a point or pain point. And then, for example, here we're looking at efficiency, and the parameters corresponding to the efficiency issue is electrical current, and then we can measure the different electrical currents, and then we can identify issues that emerge at different times. So we set up the sensors, and then we extract data, and then we identify the root problems in order to address the issues. So by setting up IoT sensors, we can visualize the situation of the production site. So the visualization can help us manage the situation before, during, and after the fact. And then we can have a visualized platform to display all the on-site information. For example, at the SMT production line, we can monitor the equipment, and then we can monitor the productivity status of the entire production line. And also we can use Line app to send or distribute production information real time to relevant people. So we can use IoT equipment to extract data, and then gradually we can expand the application, and ultimately we can come up with a smart manufacturing roadmap. Let me give you another example. This is a factory that produces packaging boxes. They have very complicated production processes. They need to deal with different sides of the boxes, the packaging boxes. And for their machines, their equipment are very sensitive. Their equipment is very sensitive to temperature. So we set up sensors to take data regarding the pace of the production, and also we set up smart meters. So after these IoT devices are set up, what kind of results can we see? First is that we can extract production data by every second, or maybe every minute, depending on the needs of the production lines. So that's the first step. We need to record the data. And also we can have real-time monitoring. So after the data are recorded, we will be able to compare the data by way of visualization so that we can see the changes in production by comparing the production volume and also the production status. And then we can predict what the future will be. In this case, we can see the production, you can see the production temperature and the production volume. You can see the temperature is dropping at a circled portion. For attaching labels to the packaging boxes, temperature is very important. So abnormality of temperature may cause quality defects. So this kind of sensing is very important.
So if we combine all the data, we will move to the upper level, that is SCADA. This is the smart factory management system we developed in-house. We will be able to monitor the carbon emissions, power usage, including the situation on the production line. Take this, for example, we will be able to know this particular pick and place general machine. You can see at the bottom of the picture, there is a bar indicating yellow, green, and red. It shows that yellow means that it's idle, green in production, red indicating failure. So with this bar, we will be able to identify the performance of this particular machine during a set period of time. We will be able to know for how long this machine has been running. The capacity utilization will also be monitored. If we combine all the data from different machines, then we have the complete picture of the production line. as you can see on the screen. At the same time, we will be able to calculate the cost, including energy cost, water usage, water cost. If you have a water meter, you will be able to calculate the cost of water used today. And of course, we pay close attention to the ambience of the office. So we do have sensors to check lighting, emissions. The same goes for warehouse environment. We can have very close monitoring of the warehouse environment. If there's too much humidity or the temperature is too high, alert will be sounded and measures will be taken to protect equipment inside. HVAC system very often is the cause of problems. We have to make sure that you don't use up too much electricity, otherwise the company may be fined by local authorities. Smart manufacturing is basically applied to the machine or production system already in the client's premises. So that is the basis. And then we identify pain points where we will install sensors. That is what I meant by from point to line to plan. In other words, you don't start installing a huge system from the very beginning. Rather, you start with small. For example, in this Thai oil mill factory, this is how they began their smart manufacturing journey. The same goes for this non-woven factory in Thailand. This is another example in a food factory. The PLC data are collected so that the temperature of the production line can be better monitored. This is another example. We help a company in Malaysia, again, by collecting data from all the machines on the production line. We will be able to provide visualization of all the production data. Most important of all, we provide training so that they can develop their own system in-house. That concludes my presentation. Thank you.
Thank you, Mr. Jerry, for the presentation. To proceed with this afternoon webinar, allow me to invite Mr. Jui-Fang Liang, Vice Chairman of Accutex Technology Company Limited, to share with us his experience regarding smart machining system integration. Participants can put forward your question in the Q&A box at your screen. Mr. Liang, I shall now pass the e-floor to you. Thank you.
Good afternoon. I am a machine maker. I make CNC EDM. So what I'm going to share with you may be a bit different from the other speakers because our company produces and develops CNC EDM, wire EDM. How can we achieve smart manufacturing? What have we done to apply smart manufacturing to the development of wire EDM? First of all, allow me to introduce to you our company, Accutex. Its headquarters is in Taichung. Accutex basically means acute technology, accurate technology. And our predecessor is a division in the Yi-Chang of Taiwan. we focus on the development of CNC. For decades, Taiwan's technology was not up to par, but now we have been able to produce CNC, very sophisticated CNC. Here you can see we have many clients based in different parts of the world. And you can see in this particular sector, our competitors are in Japan mainly and in Switzerland. Why there are so few CNC makers? It's because it's very difficult to get the key technology for wire EDM. You have to develop your own core equipment, including lathe, water, and temperature control systems. So it's very highly integrated solution. There are a few existing solution providers, not to mention the solution we are looking for must be very accurate, precise, and cost-effective. So because of the demand for CNC software and hardware, once they are developed, it will be easier to meet the need of Industry 4.0 because we control the CNC hardware and software. We will be able to help our clients. Usually, we can provide very ready to be used product for our clients. Of course, communication and discussion with the client as to the specs are still required. Otherwise, we can pretty much provide all-in-one solution for our customers. And that's something quite unique about our company. Here's the range of our products. You can see the different sizes. Wire cut is usually used for mold manufacturing. There's something unique about mold. In most production lines, usually there's a set production quantity, but for most, usually you only need one mold. However, if you want to become Industry 4.0 compliant, you need to go for automation, auto design, automatic feed of material, automatic detection. These are the criteria of Industry 4.0 or smart manufacturing. So we have to do more than just automation. In Taiwan, there are many machine makers. They have come up with their own version of Industry 4.0 software or SCADA. They have their own MES systems. They develop their own detection system. I asked these companies, among their clients, how many of their clients use products only from their company? I think many big companies dare not say, yes, 100%. Masak, one of my friends has 100 Masak and 50 well-known machines from major big makers, but at the same time, in the factory, there are also local made machines. So you can imagine there's a mixture of machines. And my friend told me that it's because Mazak is able to monitor only 80% of the machines in our factory. So I have to install other SCADA to monitor the remaining 20% machines. So this is quite tricky. We need to think about whether we need to come up with our own monitoring system or oversight system. I think the answer is negative, because each company produces each company has a number of different machines. And all these companies have their own ERP or MES systems. How do we come up with something that really meets the needs of our customers? I think this is a question all machine makers have to think hard about. That is why we have come up with the API. Since our clients in Europe, Italy, Southeast Asia, and the United States, or our clients in Taiwan, have been telling us they have the need for Industry 4.0 solution. However, they already have ERP, MES, and existing machines. They want to extract data in our machines, and we will communicate with their MES system or their MES suppliers. And then we provide our API for them. This API is linked to their MES system. In the MES system, there will be an interface for us. So the clients will find it easy to gather data in our machines. You can see this is a huge plus for their management, because their existing ERP and MES system need not change at all. And there's also a forecast system. Again, this can be used by many of our clients. With this forecast system, they will be able to connect with their end equipment. If the client wants to build a new system, the client wants to have a new complete system, we need to provide a total solution which is able to retrieve, store data, even from the design stage to processing, oversight, manufacturing, processing, report. This platform can be very helpful. We have been working with local companies like CPC SCADA or PMC SCAD Mask or SingForce. These are all examples of platforms to connect data. In fact, this system can be applied to different makers,
including machine makers or CMM makers or CAD manufacturers. The data can be linked. I'll provide more explanation later. From digitalization to Industry 4.0, we need something visual that can be visualized or something that can be used for prediction. This page probably the most comprehensive page that contains a lot of information when it comes to smart manufacturing, but it's very complex. You probably cannot see all the words very clearly. You can see a CAD system here. So when you need a project, when you have a project, you need to begin with a design. From CAD, you need to be converted to CAM, and then you need to conduct simulated analysis or structural analysis. That is for CNE, and then different programs will be required, for example, for molding or CNC. And then if you need certain precision you need a measurement at the stage of CAD and CAM, the measurement critical points will be generated. And we can use RFID to control different flows. This is about CAD/CAM. And then you need to consider the procurement requirement, and then you need to conduct BOM analysis, and then you need to consider what kind of materials or what products should be procured externally. And then you need to procure or obtain sensors for conventional machines. You need to PLC control or data extraction. For more advanced machinery may have OPCA standard interfaces. So this is the operating and management system for the molding industry. So the major items include CAD/CAM, PLM, ERP, MES, MOM, and IoT system. This is a very large system. If you in Taiwan, we need such a huge system. Will cost 150 million NT, just the software alone. I think this is an architecture for companies that would like to embark on the journey of Industry 4.0. You can adopt a step-by-step approach. Well, my pointer is running out of battery. It's not responsive. Next page. Next page. I feel kind of uneasy without a pointer. This slide depicts the SimForce intelligent manufacturing system from the left to the right, beginning from the beginning of a project to the end of the project. You can see different stages through, for example, project management. Project management and quotation, ESI, a model simulation. And then purchase system, inventory systems, CAPP, and to CNC programming, and CAD/CAM system, EDM. And after processing, there is automatic measurement taken. And then you can use self-guided vehicles or robots for transportation. And then you can use RFID for system determination. And then a corresponding program will be activated. So that's the smart manufacturing structure I just talked about. For a machine maker, the final two layers, shop floor level and control level, they fall within the scope of CNC. So the data will be sent upward to data SCADA or MES. Now I'd like to talk about the smart manufacturing system using our wire electrical discharge machining, or WEDM. First of all, we use a CAD/CAM for design. And then as a result of the design, at the CAD, you can, it will generate the CAM path or three-dimensional paths. And then three-dimensional measurement programs will be activated. And then through the RFID of the same workpiece, we know what are the critical points to be measured. And then data will be sent to the cloud for computing. And then you can have automatic scheduling or programming. Because we have a network line connecting with the central system. So all the SIM-force information or equipment related information can be extracted. We can get whatever information the customers need. This system, this machine has automatic feeding system, and there is an automatic system that automatically remove waste. And also in this system, you can see an automatic warehousing system. So from the beginning to the end, the people don't need to handle any machine. People just need to prepare the materials in the warehouses. The entire processing takes place, fully automated. For WEDM for smart manufacturing, I think the processing should be consistent. We need to have automatic threading functions. We need to have automatic mode calibration function, and also automatic waste removal function, and also information connection function. I'd like to give you 2 examples. In the past, we rarely did that. The first is in the automatic collection of waste. In the past, even though you may have automatic feeding, the waste still needed to be removed manually. So that's probably the only handicap for the automation of CNC. This is also maybe perhaps the largest hurdle. To address this issue, a few years ago, we started to design an automatic pickup step for waste. Traditionally, it was handled by workers manually. Ultimately, we developed a function in the equipment or in the machine. Towards the end of the processing through the determination by the machine, there is information that can be generated, and then a device will be used to pick up the waste. So for a mode, you can see many holes because this is a mode. A lot of there are a lot of wasted materials, and the machine need to determine the processing status and also the voltage status so that the waste can be properly removed. Another function is, in the past, for a workpiece, when you mount a workpiece, we need to adjust or calibrate the horizontal and vertical orientation of the workpiece manually so that we can achieve proper alignment, but it could not be automated because the manual labor will be required. Or I can buy very expensive fixtures, or but you need to have very time-consuming calibration. So how can you ensure proper precision? And then we came up with a method. We set up a 3-directional probe. So after the workpiece is mounted, actually, we still need a probe for final calibration along different planes. And after the calibration, the program will accommodate or will perform a rotation based on the result of calibration. So this is the most important benefit that can be generated through the programming like this. So this slide depicts automatic mode adjustment. You can see calibration is also conducted automatically. So in addition to what I described, that is, we had our API for connection with SimForce, or we had automatic threading and also automatic pickup of waste and also mode calibration. And then in combination with CAT and also the robots, we can come up with, we can address the smart manufacturing needs of a factory. And this slide depicts the steps required for smart manufacturing in the context of wire EDM. For example, you need to define the aspects of parts processing. You can see that for this particular workpiece, there are different, we are not just talking about wire EDM, there may be other working processes or other engineering steps. We can have automated division of workflow in the factory like this. This is the picture of the company's shop floor on site. And we show this to our visitors. And what you see is just automation, but you don't see how information flows are automated. This is a robotic arm. We can have an automatic pickup, and then the workpiece, the holes on the workpiece can be punched, and then the robotic arm can be withdrawn, and then we can perform other wire cutting related steps. And then our threading, after punching holes, we also had automatic threading, and after automatic threading, the processing will then continue. Of course, this is fast forward, but after the process, you can see that this step actually in the process, the waste have been picked up and discarded. You can see electrical magnetic disc that pick up the waste, and then you can see after the waste is discarded, the second step of processing is conducted. I think I fast forwarded the video clip at 50 times. Actually, it doesn't take that. It doesn't run that fast. It will take about 2 hours for this to be completed. So what you have just seen is part of automation. All the information has been integrated automatically. People don't need to operate or man the machines.
Okay, that's all. Thank you.
Thank you, Mr. Liang, for your excellent presentation. To proceed with this afternoon webinar, allow me to invite Mr. Tsai Yi-Chang, Manager of CPC, to deliver the case study of smart manufacturing on Xiamen Garment Company Limited. Over to you, Mr. Tsai.
Thank you. Dear friends in Malaysia and Taiwan, distinguished guests, good afternoon. I am Yi-Chang Tsai from CPC. I think the pandemic in both Taiwan and Malaysia is very serious. I think it's quite a luxury that we can still meet virtually thanks to the technology. Next, I would like to share with you a case study of smart manufacturing on Xiamen Garment Company. This is a client of CPC. We have been providing consultancy for that company. This is the outline of my presentation, a brief introduction to the product, to the production factory, what problems needed to be solved, what have we done to help them. So this is a factory based in Xiamen, China. It is one of the largest outdoor and sports gear manufacturers. It was funded in 2002, and the products were exported to more than 50 countries, including Canada, the US, England, Germany. Before 2009, manual work was predominant, but gradually is shifting toward smart manufacturing. As for their product items, outdoor clothing, sport gears, fitness clothing. Later, I'll talk about a pictorial system. In other words, when they built the production line, the pictorial system will be the main system in control. In other words, for each workstation, the pictorial system will determine how this fabric will move from this stop to another stop. So what are the problems? There are 5 problems. The first one is the performance of the production line cannot be monitored right away because manual work was used. But gradually, with the pictorial system installed, they had a better idea. However, they still were not able to monitor the defect rate, the performance of production line workers. Therefore, we began to introduce the visualization system, which must be combined with the MES and ERP system. Another problem is, in addition to this factory in Xiamen, the company has other factories in different cities. So in order to have comprehensive grasp of the production efficiency, we have introduced the Kanban system. In addition to performance monitoring and evaluation, we would also like to improve the on-site management. So smart improvement to the online operation was introduced so that defect rate can be better controlled. So, of course, this company also faces problems in relation to warehouse management and salary management. However, my talk will focus on efficiency and performance improvement. Here's the framework of the smart system. From the bottom, you can see there are 2 production lines. On these 2 production lines, we installed the sensor-enabled visualization system. So we will be able to see the yield and the defect rate. Improvements can be made accordingly. I talk about the on-site management. Again, the monitoring system will be installed along the production lines. There's also the heterogeneous system integration. From different systems, we can gather data and present them in our visualization system. At the same time, we combine the cloud system so that better communication can be achieved among different factories and the headquarters. The headquarters, as a result, has a better control of the operations in different factories. So this is the heterogeneous system, information system I was talking about. At the bottom, there is the PLC plus sensors. Again, they are built on the existing productorial system. However, at this level, you cannot visualize performance. That's why we have to combine ERP. Then we will be able to incorporate the workflow and staffing information. Again, data across different factories can be monitored in real time. So the manager can do such monitoring remotely, analyzing what problems may have arisen, what action must be taken to address those problems. Again, back to the hardware, to the bottom left, there's sensors, PLC, and SCADA. Basically, this system is used to collect data of the production lines and sent to our computation center. So for the red dotted lines, they represent virtual installations. As for the purple lines, solid lines represent the software installation, the brick and mortar system. Next, I'll talk about the production performance visualization, as well as the other two elements. First of all, the production performance visualization. On the screen, from the left to the right, you can see the steps taken to build such a system. To the far left, traditionally, we have paper-based system. We have to print out the table and then you fill out all the tables. However, with such a manual system, you cannot have real-time monitoring and analysis, and there may be errors. In the middle, in 2018, there is uniform tables, and also the proctorial system was introduced. With the proctorial system, you can gather a certain amount of data, but it cannot be combined with other systems. That's why in 2019, to the far left, to the far right, we introduced the smart system where online system and ERP can be combined so that everything can be visualized. Smart factories, we know, has key elements in visualization and real-time monitoring. So real-time clarification and visualization are essential because with grasp of the current situation, you will be able to make adjustments and improvements in real time. So this is the dashboard we built for the system. The key is on the left, that is the production efficiency visualization. In the middle, goal setting. Why do we want to talk about goal setting? When we combine heterogeneous systems, we notice that maybe certain information is missing in some systems. For example, in this case, the client system does not have any goal setting function. So we decided this is something that must be strengthened. To the right is about salary calculation. Now, let's look at the visualization system in further detail. Here you can see the production real-time overview. For example, you can see the situation on different production lines. Those in the orange boxes are the 2 production lines at work. So with this dotted lines, you will see how many production lines are on, what items are being produced. Most important of all, the achievement rate and the rework rate. Rework rate is a proxy for defect rate. In other words, there are defects with certain products. They have to be returned to the production line. And there's also green light. Green light means everything is normal. Yellow light indicates warning. Red light indicates anomaly. Basically, the rework rate will determine which production line will have red light. And of course, there's more detailed information about each production line. For example, like here, you can see the actual progress of production hours of all divisions. For example, the kind of items that is being processed on this production unit. There's this item number, order number, the number of workers on this production line, the expected turnaround. At the bottom, we will be able to see the different workstations along the production line. So we will see the progress. We can also have a better idea of the WIP. This involves the proctorial system. The proctorial system can dispatch semi-finished products to different workstations. Certain workstations may be jammed or overloaded. Some workstations may be idle. There are no semi-finished materials or products to work on. So we can have a clear overview of the different workstations. Again, through this chart, we can grasp the progress, the working progress on different divisions, units. Again, if we look further, you can see the production line schedule progress. On this production line, we will see how the progress is going on based on the ERP information. In other words, there's a lot of data exchange and integration going on. We thus have a better idea about when the production begins on this production line. The achievement rate can be monitored too.
Now, we can look at the different work orders and to determine the progress of our production lines. You can see the daily production volume based on the work orders. And then you can see details about the daily production. And also, you can look at this from the angle of personnel. If you look at the top half of the slide, you can see the processing quality. You can see the achieve rate of each operator. And also the table can depict information such as employee number and also their target, and also how many defective products are generated. And then we can use all the different information to calculate the achieving rate. And the table below on the second half of the slide, we can determine the production efficiency of the workers. And you can see 3 red dots in the beginning. We use the lights to depict the current working status of the workers so that their staff supervisors can intervene appropriately when the efficiency is too low. So I just introduced the visualization system. Now, after the step of visualization, we also work on the headquarters situation Kanbans. And after the visualization step, the following step is not very complex, but for different production sites, the most important issues include integration of the data and also the transmission of data. That is, there are different systems set up in different production sites, and the data from different production sites should be properly integrated and displayed in the headquarters situation Kanban, and the managers can make decisions based on the information displayed on Kanban. And currently our practice is that we have a headquarters in Xiamen and also in Yidu and also Fuzhou. We have our factories there, and the information from the factories can be sent to the cloud system, and then we convert the data format before the data are transmitted to the cloud system, and ultimately the performance data can be displayed on the headquarters Kanban. So at the time of deployment, we ran into issues relating to data integration. For smart factories, real timeliness is very important. As you can see in the left, there's a smart system. The system will extract the databases from the production sites in different places. But as a result of this arrangement, the data transmission efficiency is low, so the information extraction can take place in midnight. So the information is not updated on a real-time basis. So we set up a relay database. So the databases in the right will directly perform the data conversion and transmission to the relay database. If they can do that separately, the efficiency will be much higher. So the operation or the conversion or transmission will take place every 10 minutes. And then the smart system in the left will collect or extract data from the relay database. And the data extraction can take place every 2 minutes or even a shorter interval, depending on your needs. So this slide depicts the headquarters situation Kanban, and it contains a lot of information, including the production value of the headquarters from Monday through Friday, including the achieving rate, and also for the monthly production value, and also the annual production values, they are also depicted. And you can see information, also information from other production sites. On the upper right, you can see today's data. And also there are different fields that are made available so that this kind of a dynamic columns can be used to populate data from other additional production sites in the future. So ERP1 and ERP2 are flexible tables, and they can be used and leveraged by MIS people. Now I'd like to introduce our smart production line management system. through the system, in addition to visualization, like I said, we can also integrate data, performance data of different production sites. And also through the system, we will manage the performance of on-site, and we can use tablets, PC to do that. And this is, you can see a visualized interface. Visualization will take place on site, and also the information is highly visible. It can be visualized in the headquarters Kanban, situation Kanban. And for on-site application, we can use a tablet PC to, through QR code scanning, we can check the matters that should be noted for the processing or for the fulfillment of a particular work order. And also, you can get information about the devices nearby, how they should be operated, so that you don't need to waste a lot of man-hour to identify or to obtain relevant information. This is a standard operating system of our smart production line management system. When you access the system, you can see the work order and also the item numbers, and now you can see the current SOP. In the course of processing, if there is anything that the operator doesn't know, the operator can switch to a relevant screen to obtain the information about the things that they should bear in mind in operating this step. We also have a design for inspection. That is, we can have a gated approach, so that in the course of production, if certain steps should be inspected, we can do that at different stages, so that nothing is left out and the information can be accurately reported, and the information as reported will be reflected in our system. And the result of the inspection may be good or okay, but if it's no good, the information can also be fed into our system. And then we can come up with statistics about the defective work pieces. And also for excluded work hours, that is, we may need to attend, you may not be working within the facility, you may need to attend meetings of the facility. We can also click on the relevant fields to input in the information, and then automatic, the excluded work hours can be calculated automatically. And then the performance and also work hours can be properly included and calculated in our system. This is a visualized Kanban that shows the current status of the production side. You can see the achieving rate or efficiency, and we can also show the work hours here. And also you can see the trend for the yield and also efficiency. And if you look at the bottom in the left, you can see reasons for defective parts. And the tablet PC can conduct this kind of statistical analysis on a real-time basis. And if you look at the lower right, which is about the statistics of excluded work hours, you can see the kind of time that is spent not in production. For example, if in internal meetings or resting. So with this kind of information, you can conduct a subsequent review for the purpose of improvement. So I just talk about the three major dimensions for developing the the smart manufacturing system. Most important aspect includes the performance monitoring system, and also we integrate ERP MI system. Because we have enhanced the efficiency in the real-time display of information, the management will be better equipped with means to respond to the needs of the production sites. And also this reduces the workload of on-site supervisors. And as a result of the system, a total of 4 supervisors can be reduced. And also we can reduce the defective rate. And because of our access to performance and efficiency data, we can make further improvement. And this is the general achievement that I can share with you right now. Thank you. That concludes my presentation.
Thank you, Mr. Tsai, for your sharing. Ladies and gentlemen, we will now proceed to the panel discussion session. I shall now pass the floor to our moderator, Mr. Jacob Lee, FMM Council Member and Chairman of MTECC Malaysia Chapter. Over to you, Mr. Lee. Attendees can put forward your question under the Q&A chat box.
Okay, thank you, Jess. And I want to express my heartiest appreciation and thanks to our speakers, Mr. Chien-Fei from CPC, Mr. Jerry Shu from ICP DAS Company, and Mr. Jui-Fang Liang from Accutex, and Mr. Tsai Yi-Chang from CPC. I think for your excellent presentation. Well, I wish to check with our speakers. Many of the attendees expressed their interest to have your slide. So would it be possible for our secretariat to have your slide and send to our attendees? Would that be possible? Yeah.
Yes. Okay.
Okay. 谢谢你们哈 Thank you very much. And I think our secretariat will then share your slides via email to our attendees. Okay. I have so far received only one question. Okay, from Mr. Muhammad Fitri Abdul Manaf. Okay, his question is: smart factory rely heavily on the sensors for automated data collection and action to be taken if there is any deviation. How do you ensure the reliability of the sensors data, especially on the external sensors, and how frequent it needs to be recalibrated or perform maintenance? Okay, the question here is talking about, in the smart manufacturing, especially in the IoT, there'll be a lot of sensors, collecting data from different points. I think his question is on how reliable are these data? How accurate can the sensors be? Does it need frequent recalibration and measurement? How can we be sure that the sensors pick up the right information and in the course of communicating the information, and how reliable that information is? Okay, I have received this question from Mr. Muhammad. Yeah, so anyone want to pick up this question?
哪一位要回答这个他刚刚的问题？哪一位？
那个两个了哈，
And meanwhile, for others participants, if you still have questions, I do encourage you to post a question as soon as possible. Yeah. Thank you.
Okay.
This is a very good question. Usually, before we install sensors, we will select the right specs to ensure reliability so that the transmission and precision will be better. As for recalibration, of course, there will be cyclical, periodic recalibration. However, I want to emphasize that not all sensors need to be recalibrated. Sometimes we just need to calibrate once to ensure the distance is correct. And of course, for sensors installed along the production line, the precision, the reliability must be higher, so recalibration will be needed. I'm a machine maker. So there are two aspects. First, the signals. Are the signals strong enough? The temperature, the electrical currents, the voltage, the humidities, vibration. So they will have an impact on the strength of your signal. If the output range is not within the spec, then there will be alarm sounded. Secondly, from the machine to SCADA, usually there will be nothing wrong with the transmission side. There will be double check function installed. Thank you. Any other questions?
Yeah, Mr. Mohammed, I hope your questions are being answered. Yeah.
Any question?
Are there any more? Okay, there are some questions here. Yeah. Now there's a question from Mr. T. Yoklona. In the sharing just now, I did not hear much about the remote equipment interface technology. Is that part of smart manufacturing? How effective it can be applied to production? Okay, maybe I ask another question from Anthony Winson. Smart factory is all about hardware, sensors, software, etc. How about ensuring effective people involvement in smart factory? Thank you. Maybe I will ask these two questions, and would our speaker, any one of you wish to pick up these two questions from Mr. T and from Mr. Anthony Winson for the time being, yeah.
API 是什么？回答哈 ，API， 来 ，API 是啥？好，我先呢。
So I'll answer the second question. Smart factory. In a smart factory, if you have money, you can buy a factory, smart or non-smart. In Taiwan, the hardware, equipment, it's all very sophisticated, but there's no guarantee that your factory can go online. There are a few factors. First of all, your management system must be in place. Even with a smart factory, you need to have good security you need to have a good system to ensure security, management, and quality. So the system or institution must be in place to ensure the proper running of the smart factory. However, we know there's TQN, TPN, the people is a huge factor. I have talked with a robotic arm maker, and I was told that 7 out of 10 complaints had nothing to do with their products defects. Rather, it's the operator who had problems. So talent development is important. If you want to do TQM or TPM, the management, the talent must be developed, and the skill level has to be enhanced, because you need to have the capability to control the IT system, the machines. Maybe I have a sports car. That doesn't mean I can join the F1 race. So everything has to be in place to make sure the system ticks. In fact, on the second floor of our center, we have AI classroom and the IO design classroom and EDM classroom. We are also building a workshop for interns where you can work on real machines. Well, maybe after the pandemic, we will open our classrooms so that more people from the APO enterprises can experience for themselves. So indeed, the smart factory will not work without the right talent. Okay, Jerry, please answer the first question. Okay, speaking of API, application programming interface, it's a very small program module, software module. With this, we can provide for our clients MES supplier, and through the core function, the client will be able to access the information or data in our machines. Because there are no standard criteria for MES and the ERP, so if the client wants to gather data in our machines, we won't have the capacity to answer all their requests. So API basically provides a very easy to access link.
Okay, thank you. I think I cannot agree enough to say that the smart factory, we need smart people to run the system. Yeah. Yes. That's the reason why we are introducing all these awareness program, education program, and upskilling program. Yeah. Okay, I want to thank the speaker for answering the question. Now we go to another question from Simon Seeker. Most of the case is for CNC industry. How will it help in a fabrication line where not much of machine involved, especially on the welding machine or process? This is from Simon. And probably another question from Sing Sing, Aaron Chu. Any reference for investment needed? Any rule of thumbs for this? So I guess you're asking for money. Is that monetary value or what? You know, maybe you can specify more clearly. And I got another question from Mr. Bala Murari. Is artificial intelligence play the biggest role in this industry? Well, I think I like this question. The AI, you know, artificial intelligence plays a very important role in this industry 4.0. Okay, over to you, our very honored speaker. Yeah.
好，哪一位？
Good afternoon. If it's a factory, there are few machines, only welding machines with a lot of workers on the production line. Does smart manufacturing work? In fact, speaking of smart factories or smart manufacturing, you have to go back to the basics. for smart manufacturing, what are your objectives? If you want to run a business from input to output, you invest money to purchase machines, set up a factory, you invest in research and development, you receive order, you produce, you ship the products. You want to accelerate the whole process. Or if you invest in R&D and you begin to produce and ship products and you reap profits, again, the turnover can be rather quick. Or if you receive order, you produce, you ship products, you have your returns on investment. Or if you produce products, you ship them, and of course, you want to accelerate the process as well. In this competitive environment, in addition to quality, speed is very critical. That's how you can meet the market demand in a timely manner. Speaking of factories where welding is the main production activity, well, again, speed is very important. You want to have a lower turnover rate. In other words, you need to know, are this equipment working properly? If there is an anomaly, can you get the information or alert right away so that you can address the situation? Secondly, quality control. In the production process, how can you monitor the quality of products? If there's any anomaly in the quality, can you get the information immediately? Smart factories usually can adjust the production equipment right away so that the yield can go up right away. Next, in the production process, you need to control quantity. The quantity actually produced must be compared with your planned outputs. And again, you need to take into account the turnaround time so that you know how efficient your production is. Therefore, smart manufacturing ultimately wants to make sure that quality in the production process can be maintained so that your production outcome can be exactly the same as you plan. If there's any problem, such information must be made available to the art manager so that action can be taken. So back to your question, in a welding factory, I believe your objectives are the same. That is management performance improvement. That's why it's even more essential you have smart manufacturing. However, the investment required may vary from one factory to another.
Actually, during the presentation of Mr. Tsai, actually, regarding the factories, the machines are quite simple. A lot of sewing machines. We're talking about very simple sewing machines and also production lines involving working people. But for a production line, actually the speed of the production line is determined by the most inefficient worker, because the worker will delay the whole process. So what is more important is the balance of the production line so that everybody can work at the same pace or the same speed. Secondly, the efficiency is very important. Also, the quality issue should be identified on a real-time basis. So when a group of people work together, a lot of issues can be neglected. In Malaysia, the labor cost is also very high. So this kind of real-time control, real-time identification of the information is also very important. And secondly, for AI, for deep learning or machine learning or computing different computer algorithm, the ultimate purpose is to provide assistance, decision-making assistance to people. But there's one thing that you need to bear in mind. The basis is really about data collection or big data. But when it comes to big data, the information may come from, the data may come from equipment for operation involving a lot of manual steps. The data may come from different data collectors. So the more the data, the better your judgment will be.
Any more question?
Well, I think, Mr. Kuo, I think our time is up already. I think all the speakers have presented very well. I think it has been a very beneficial session. For those unanswered questions, you may send or you may still have questions. I would want to encourage the participants to write to FMM, and we will continue to communicate by email with CPC, Taiwan. Okay. For the close, I want to give my acknowledgement to Dr. Kuo-Ming Wang, the Managing Director of China Productivity Center, CPC. And I also want to thank Mr. Rosmi of the MPC Malaysia, and all our speakers, Mr. Jerry Shu, Mr. Jui-Fang Liang, and Mr. Tsai Yi-Chang. I hope I did not miss out anybody. I want to thank you all for your excellent contribution and the participants for your participation. Okay, with this, we hope to extend our warmest welcome to our Taiwanese friends when we are ready for traveling, and please do come and visit Malaysia, and we want to visit you also in Taiwan, and we wish you the best of health and stay safe.
Thank you.
Yeah.
We'll keep in touch.
Thank you. 谢谢.
Thank you.
Thank you. Thank
Yeah.
you, Mr. Jacob Lee and our panelists today for the insightful information. Thank you everyone for attending today's webinar. On behalf of FMM, I wish to thank all the panelists and participants for your support towards the program. We look forward to your participation and support in our future programs. Thank you so much.